We are continuing properties of exponents, rule 4. When dividing two exponents with the same base, subtract the powers numerator minus denominator. Okay, so we have 6 to the 14th over 6 to the 8th. Okay, rewriting that using repeated multiplication. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Just barely fits. With a multiply between those, obviously. Okay. And 6 to the 8th. 1, 2, 3, 4, 5, 6, 7, 8. Okay, what is 6 divided by 6? Well, it's 1. So all of these that we can cancel out cancel to 1. And when we multiply by 1, it doesn't change anything. So what's left is 6. 1, 2, 3, 4, 5, 6. 6 to the 6th power. The shortcut using the rule would be 14 minus 8, which is 6. Okay, now using the rule over here, we have the same bases. The exponent here is 7. The exponent here is 2. 7 minus 2 is 5, so it is negative 5 to the 5th. Okay, remembering our rules from yesterday, looking at just the numerator. Okay, we have 12 to the 5th times 12 to the 3rd. They have the same base, so we add the powers, 12 to the 8th over 12 to the 4th. And now we have 12 to the 8th divided by 12 to the 4th, which is, when we subtract the powers, 12 to the 4th. 8 minus 4 is 4. Okay, that brings us to rule 5. Okay, distribute the power. Through Okay, distribute the power through to all items multiplied in both the numerator and the denominator. Again, it only works for terms multiplied and divided, not adding and subtracting. Okay, so looking at this example, we have 3/4 to the 5th. Okay, I'm going to rewrite that using repeated multiplication. 3/4, 3/4, 3/4, 3/4, 3/4. Okay, how do we multiply fractions? Straight across. So I can rewrite that as one fraction, multiplying all my tops, or numerators, and multiplying all my bottoms, or my denominators. Okay, but how many 3's is that? That is 3 to the 5th over 4 to the 5th. Notice I could just distribute my power to both the 3 and the 4. Okay, so we're going to do that here. The negative stays out front, 1 to the 6th and 5 to the 6th, distributing that power. Okay, however, what is 1 times 1? 1. What's times another 1? It's still 1. Times another 1? It's still 1. No matter how many times we multiply by 1, it's always going to be 1. So I don't want you to leave that 1 to the 6th power. I want you to just simplify that as 1. Okay, but since there's no variables, we can leave it as 5 to the 6th. Okay, and that brings us to rule number 6. Okay, so we can treat them like fractions. We can divide them by 1 without changing anything. We can multiply them straight across. Okay, so I have an exponent times a fraction with an exponent. So I'm going to make them both look like fractions by dividing the 3/8 by 1. Now, I have a fraction times a fraction, so I'm going to multiply my fractions straight across. 3 to the 8th times 1 is 3 to the 8th. 1 times 3 to the 1st is 3 to the 1st, because multiplying by 1 doesn't change anything. And then I have 3 to the 8th over 3 to the 1st, which I subtract my powers, so 8 minus 1 is 7. Okay, done. Okay, applying that and the other rules to 7. Okay, I'm going to distribute my power. 1 to the 5th over 4 to the 5th times 4 to the 13th. Okay, 1 to the 5th is just 1, right? 4 to the 5th times 4 to the 13th. Okay, now this is a fraction. I'm going to make this one look like a fraction by dividing by 1. 1 times 4 to the 13th is 4 to the 13th. 4 to the 5th times 1 is 4 to the 5th. And then 13 minus 5 is 4 to the 8th. Okay. You do on your own 10 through 15 and double check them up here. You should have the video paused and be doing these on your own. I hate Z's. Okay, on this one, since we have numbers and variables, I want you to evaluate the numbers. 6 times 6 is 36, times 6 is 216. So we have negative 216 divided by z cubed. That is our answer. Okay. And the last one, distributing. The 3 is multiplied by the x to the 4th, so the 3 also gets a 5th power. 3 to the 5th, x to the 4th, to the 5th, y to the 6th, to the 5th. times 3 times 3 times 3 times 3. Okay, power to a power, multiply those powers. Power to a power, multiply those powers. 3 times 3, 9, 27, 81, 243, 243, x to the 20th, oops, y to the 30th. Okay, cell phone subscribers. The table below shows the approximate number of cell phone subscribers in selected countries in 2001. How many times greater is the number of cell phone subscribers in Poland than in the Solomon Islands? Okay, we are going to find out how many times the number of cell phone subscribers in Solomon Islands fits into the ones in Poland. So we're going to divide the cell phone subscribers in Poland by the cell phone subscribers in Solomon Islands to figure out how many times it fits. So 7 minus 3 is 10 to the 4th more subscribers. Okay, how many times greater is the number of cell phone subscribers in the Dominican Republic? Is 6 over Solomon Islands is 10 to the 3rd. So that would be 10 to the 3rd more. Okay. Glass vase. You are taking a glass blowing class and have created a vase in the shape of a sphere. The vase will have a hole in the top so you can put flowers in it. It will sit on a stand. The radius of your vase is 21/2 inches. Use the formula V equals 4/3 pi r cubed to write an expression for the volume of your vase. Okay, so 4/3 pi r cubed. Well, r cubed, r is 21/2. Okay, now we're going to distribute that power. 4/3 pi to the 9,261 over 2. Okay, I did that by 21 times 21 times 21. Okay. Oh, 2 cubed, which is 8. Why did I not simplify that one right away too? Oh my goodness, losing my mind. Okay, now I'm going to multiply through, and I get 37,044 pi over 24. Okay, multiply that out on times 3.14159 divided by 24. B equals 4,849.04 inches cubed. Okay, so if we were making these in a factory and we made a bunch of them, and then we had that spray foam stuff that they put in vases at flower shops now, so that when you put the flowers in, they stand up nice, and it holds the water better, we could put this into a computer and have a factory and a machine fill all the vases with the right amount of foam stuff without wasting foam or having to have a person do it by seeing whether they filled it up all the way.